everybody, it's Miss V again. Welcome back. So yesterday I put up a question in Google Classroom asking you to post any questions from this booklet or from the white booklet that you've been having difficulty with, and I said that I would go through them today in a video. The only little hitch that there is with this plan is that it requires me to have answers. So unfortunately nobody replied back with questions that they're struggling with, which either means that you guys are all understanding this perfectly, which is awesome, or that you're not watching the videos. So I really want to encourage you, please make sure that you're watching these videos as they're posted, right? These are still meant to be daily lessons, so please make sure you're following along. I don't want you to feel like you're going to be overwhelmed when it starts adding up. So since no one asked specific questions, I think we'll just go through some more of those written response questions at the very back. Okay. Specifically, how to draw Bohr and Lewisdot diagrams for single atoms and compounds, because that is something we learned at the very beginning, so we might be a little rusty on it. So for the question number 1, we're just going to do one of these. Okay. It says, draw a Bohr diagram for the following atoms, oxygen or sodium. I'm going to go ahead and pick oxygen. So a Bohr diagram is different because it will show you exactly how many electrons are found in each valence shell. It's going to show you all of the electrons, whereas a Lewisdot diagram only shows you the ones in the last shell. Okay, so very first thing I'm going to do is I'm going to write down my symbol for oxygen. I need to know its number of protons and number of neutrons, right? And in order to find that out, I'm going to have to look at a periodic table. Okay? So I need to find oxygen, okay? And I can see that its atomic number is 8, and its weight is 15.999. Well, we're just going to round that up to about 16. Okay? You always want to round it up to the nearest whole number. Okay. Now, this number right here, 8, my atomic number, that tells me how many electrons I have, as well as protons. Those numbers are always going to be the same for an atom. So I know that my protons is 8. My neutrons, on the other hand, in order to figure out my number of neutrons, it's the atomic mass minus my atomic number. Okay? So in this case, my mass, right, if you're forgetting where things are found, you can always look over here. My atomic mass is the lowest number on the table for each section, so it's this number right here, 15.999, and we're going to round that to 16. 16, and the atomic number, right, is 8. So 16 minus 8 is 8, right? It's not always going to be the same number, so you always want to double check and put a circle around it. Next thing we need to do is now draw our electrons that are going to be in the shells around our nucleus. So I know that I'm going to have at least one shell, so I'm going to go draw that in. And you should remember our 288 rule. So only 2 electrons can fit in my first ring, 8 electrons can fit in your second ring, 8 can fit in the third ring, and if you really need to, 8 can also fit in the fourth ring. Okay? So I know that I need 8 electrons because it's the same number as my protons. So I'm going to go ahead and draw in 2 here. That's the max amount that I can put in my first ring. So I'm going to need a second ring. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I've drawn all of the electrons that are going to be in my oxygen atom and in the proper formation, and now we're finished. Alright, moving on down. Okay, we are also going to look at how to draw a Bohr diagram for compounds. Now, these ones, right, lithium fluoride, magnesium oxide, they are both ionic. Now I know that because magnesium is a metal and lithium is a metal. Remember, ionic compounds have a metal and a non-metal put together. Okay? You should also remember that metals are greedy, right? So they are always going to give or take electrons. We're never going to draw them like they're sharing. And hopefully you remember that this is when we have to draw our brackets and our charges. Remember, whenever you have ionic compounds, you need to draw those brackets and charges. That is where most people get mixed up and lose marks in this part. So we're going to try drawing lithium. Alright, so I need to look at lithium. Okay, I know that it has an atomic number of 3, and we're going to round the mass to 7. Okay, so I have 3 protons, and my number of neutrons is going to be 7 minus 3, which is 4. Okay, and I also know I'm going to have 3 electrons, so I can put 2 in my first ring, and in order to make that 3, I'm going to need to put 1 in my other ring. Alright. There we go. And now I need to also draw fluoride, which is fluorine. So I can look at my periodic table. I know that fluorine has a atomic number of 9 and a mass of about 19. So I'm going to go ahead. Nine. My neutrons is going to be 19 minus 9, which is 10. Okay, so once again, I have 9 electrons because I have the same amount of electrons as I do protons. 1, 2. 3, 4, 5, 6, 7, 8, 9. And so now we're in an interesting situation. You can see that fluorine needs an extra electron, whereas my lithium wants to give one away. So we're kind of in, a perfect world here where I need to give one, you need to take one. So that's what we're going to go ahead and do. So we're going to take away this extra electron here. Right? Now that that is stable, right? It has a full shell now. You could erase this entire shell if you'd like. And we're going to bring that electron over here. Now fluorine is full and stable. Perfect. So now I cannot forget to draw those brackets and charges. Because now that it is either given away or taken electrons in order to become stable, these are now not regular atoms, these are ions. Okay. So I have my brackets, and now I need my charge. So lithium gave away a negative electron, right? It got rid of a little negativity in its life, so it became more positive. It became positive by 1 because it got rid of 1 electron. Whereas my fluorine, is negative. It gained negativity from gaining that negative electron, and it gained it by 1. Okay, so in other words, my negative ion is actually an anion, and my positive ion is now my cation. Okay? So go ahead and try and do B on your own and see if you can get the hang of it. And we're going to move on to number 4. Okay, now we're moving into some Lewisdot diagrams. Lewisdot diagrams are a lot simpler. You're only drawing the electrons that are in the outer shell, and you don't need to write down your numbers of protons or neutrons, which makes them a lot simpler. However, you do have to be a little more savvy with that periodic table in order to know what's going on. So we're going to go ahead and try and do the first one. Right? And the very first question I always have to ask is this an ionic or a molecular compound? Right? So if I look, barium is a metal. Okay? It is found on the left-hand side of my periodic table from the staircase, so I know that it's a metal. So that means that this is an ionic compound. So once again, I'm going to draw it with brackets and charges. Only difference is that now I'm going to draw it using that Lewisdot style. Okay, so I'm going to go ahead. Lost me. All right, and draw in my symbol. Okay, and you may be thinking, oh my gosh, I have to count out like 56 electrons and know like how many end up in the last ring. You don't. There's a very nice trick to this. If you're trying to find out how many electrons are in the last valence shell, all you need to know is what group it belongs to. So barium belongs to group 2. So see how it says 2V? It means it has 2 valence electrons. Okay, so I can go ahead and just draw in my 2 valence electrons. And my next one is iodide, which is iodine, right? Which is 53. Once again, we do not have to count all those electrons. I can see that it is in group 7 or 17, or it has 7 valence electrons. Let me go ahead and draw that one in as well. 1, 2, 3, 4, 5, 6, 7. Okay. And so, this is where it gets a little tricky. Well, my iodine can take 1 of these electrons, but it's going to have to leave this extra one behind. So what I could also do is actually draw in another iodine. Right. Alright, so now 1 electron will go to the iodine on the right, and 1 will go to the iodine on the left. So I'm going to go ahead and erase them from here. My barium is now stable. It's gotten rid of those extra electrons. Iodine has gained them. And now I need to remember to add my brackets and charges, because these are now ions. Okay, so my barium got rid of 2 negative things, right? Got rid of some negativity from its life. It became more positive by 2, because it got rid of 2 electrons. And each of my iodines gained 1 negative electron. Gained some negativity in its life by 1. Alright. So there we go. That would be our ionic bond right there. Next one that we're going to do is for question number 5. We're going to draw a Lewisdot diagram again. And we're going to draw one for sulfur dioxide. So the question that you have to ask yourself here is, okay, is it a molecular or ionic compound? When you look, sulfur, and what was the other one? fluorine, right? We already know that fluorine is over here. They are both on the left-hand side of my staircase, so they are both going to be nonmetals. When I have two nonmetals bonded together, that is a molecular compound. So, when I draw molecular compounds, I have to make sure that I draw them like they're sharing. So we're going to go ahead and do that right now. Okay, so I'm going to draw sulfur. And I know that sulfur is in group 6. So it has 16. So it has 6 valence electrons. 1, 2, 3, 4, 5, 6. And fluoride, difluoride, right? Whenever I see di and it's molecular, right? Those are the naming rules. That reminds me that there's 2 fluorines there. Di is Latin for 2. Okay, so I'm going to draw 2, and they're in group 7. So here we go. 3, 4, 5, 6, 7. And I'm actually going to do this because it'll make it a little bit easier for myself. I'm going to bring this electron down here and draw my other fluorine on the other side. 1, 2, 3, 4, 5, 6, 7. And now for this one, all you do is actually connect those electrons. Right, so now they are sharing these two. So if I were to count 1, 2, 3, 4, 5, 6, 7, 8, right? Fluorine is stable and happy. 1, 2, 3, 4, 5, 6, 7, 8. So is sulfur, and so is my other fluorine. Okay, so this is how you would draw for a molecular compound. All right, so that is all for today. I hope that that made sense. Please make sure that you email me if you have any questions whatsoever. If you would like to send me an email with your completed booklet, either this one or the white one, I will give you a bonus mark for completing those prior to your assignment tomorrow. Also, please feel free to email me if you have questions on the assignment tomorrow. That's what I'm here for, guys. All right, have a great day.